Ever heard of perfect numbers? They're kind of like, the unicorns of the math world.
Oh, yeah.
A little magical, a little mysterious, and maybe even a little mythical.
Yeah.
You sent us some fascinating research on this topic,
Oh.
specifically a paper
Yeah.
called Improving the Bound on Prime Divisors of Odd Perfect Numbers
Right.
by mathematician M.A. Popov.
Okay.
So get ready for a deep dive into the world of perfect numbers
Yeah.
and the ongoing quest to find one that's a little odd.
It's a puzzle that has captivated mathematicians for centuries.
All right, let's break this down for our listener.
Sure.
What exactly makes a number perfect?
So a perfect number is a number where all of its divisors,
Okay.
the numbers that divide into it evenly,
Right.
excluding itself, add up to the number itself.
Mhm.
Take the number 6, for example.
Okay.
1, 2, and 3 all divide evenly into 6.
Yep.
And when you add them together, 1 plus 2 plus 3,
Mhm.
you get 6.
Ah, perfect indeed.
Yeah.
So that part seems pretty straightforward. Right.
Where does the odd part come in?
Well, all the perfect numbers we've discovered so far are even,
Oh.
and we have formulas to find them.
Okay.
They're quite predictable, really.
Mm-hmm.
But odd perfect numbers,
Yeah.
those are the real enigma.
Right.
No one has ever found one.
Ah.
But mathematicians haven't given up on proving whether they exist or not.
So how do you even begin to prove something about a number that might not even exist?
Right.
It's like trying to find evidence of a ghost.
Yeah, that's where the concept of a bound comes into play.
Okay.
Imagine you're searching for a lost earring on a massive beach.
Uh-huh.
It would take forever to sift through every grain of sand, right?
Yeah.
But if you know your earring must have landed within a specific area,
Right.
your search becomes much more manageable.
Okay, I like that analogy.
Yeah.
So this bound helps narrow down the search for odd perfect numbers.
Exactly. It limits the possible values of the building blocks of these numbers.
Okay.
They're prime divisors, prime numbers like 2, 3, 5, 7.
Right.
Can't be divided evenly by any other whole number except one in themselves.
Yeah.
This paper is trying to refine that search area
Okay.
by improving the known upper limit for how big these prime factors can be.
The paper mentions a specific formula for this bound.
Right.
Something like P is less than 3n to the 1/3 power.
Yeah.
That's enough to make anyone's head spin.
Yeah.
Can we unpack that a bit?
Of course, in essence, this formula says that any prime factor P
Uh,
of an odd perfect number n
right.
must be smaller than the cube root of 3 times that perfect number.
So finding a tighter bound helps rule out a bunch of prime numbers,
Exactly.
making the search more focused.
Right.
But what really caught my eye was the mention of using AI,
Yeah.
specifically these large language models, DeepSeek and Grok,
Huh.
to tackle this problem.
Yeah.
AI is getting involved in number theory now.
Yeah. It's pretty amazing.
That's wild.
It is.
Did the AI have any groundbreaking insights?
Was it like, Eureka, here's the odd perfect number you've all been waiting for?
Not quite. Both DeepSeek and Grok suggested similar avenues for exploration,
Interesting.
which is intriguing.
Okay.
But the paper emphasizes that these are just speculative statements.
Right.
AI brainstorming, if you will.
Yeah.
We still need good old-fashioned mathematical proof
Okay.
to validate anything.
So the AI is more of a research assistant
Yeah.
than a mathematical mastermind?
A good way to put it, it can offer potential leads and spark new ideas.
Right.
But the rigorous task of proving those ideas still rests with mathematicians.
Makes sense, but then the paper takes a fascinating turn.
Oh, yeah.
The conclusion is titled, Human Simplest Proof of Non-Existence of Odd Perfect Numbers.
Right.
That sounds pretty definitive.
Doesn't it? Popov shifts gears completely,
Oh, yeah.
moving away from AI
Mm-hmm.
and presenting his own argument
Okay.
for why odd perfect numbers can't exist.
Okay, now I'm really intrigued.
Yeah.
What's his argument based on?
He starts with an observation about even perfect numbers.
Okay.
They can always be represented as the difference between two even numbers.
Okay.
For example, the first perfect number 6
Right.
can be expressed as 8 minus 2.
I see. But how does that connect to odd perfect numbers?
Well, Popov noticed a pattern in these differences.
Okay.
He realized that all even perfect numbers can be generated using the formula 2n times the quantity 2 to the n plus 1 minus 1,
Okay.
where n is any positive whole number.
Mm-hmm.
This formula always results in the difference between two even numbers.
Which, of course, will always be even.
Exactly.
I'm starting to see where this is going.
Precisely, Popov concludes that since the difference between two even numbers
Right.
is always even, there can't be an odd perfect number.
Huh.
It's like saying you can't mix blue and yellow paint and get red.
Right.
The very structure of perfect numbers as we understand it
Yeah.
seems to rule out an odd one.
Wow, that's a bold claim.
It is.
It's a beautifully simple argument, but is it universally accepted in the math world?
That's a great question, and it gets to the heart of how mathematical knowledge evolves.
Yeah.
Math isn't about blindly accepting claims.
Right.
It's about rigorous scrutiny and debate.